Today's lesson will cover some of our derivative rule shortcuts and tangent lines, writing the equation of a tangent line. So remember, d dx means that you need to differentiate with respect to x. The most common use of that would be to differentiate y with respect to x, because that's how most relationships are written. So the power rule states that when we differentiate anything to a power, we can pop down, power down, x to the n. So we pop this n down and multiply it by the coefficient that x has. So here it's 1, n times x, and then we subtract 1 from that power. The derivative of any constant, any number, is 0. The scalar multiple rule. If you multiply by a number, then the derivative is the same, just multiplied by that same number. And if you add derivatives, you can derive them separately or subtracting derivatives. This sort of rule does not work for multiplying and division. So the derivative of x to the fourth, pop down, power down, 4 times x to the 4 minus 1. Oh, that's 3. Great. Pop down, power down, negative 2/3 is my coefficient. Now x to the negative 2/3 minus 1. So negative 2/3 minus 3/3 is negative 5/3, plus the derivative of 3, that is 0. Your answer shouldn't have a negative exponent, so just go ahead and clean that up. Y prime is how we say this, or f prime of x, that little apostrophe, is going to be negative 2 over 3x to the 5/3. It is fine if you leave a fractional exponent in the denominator. H of t. Right now we have a fraction, which would require the quotient rule, but we're not studying the quotient rule right now. And actually, it might be easier if we use the power rule. So we can rewrite this function as 5 minus. Now I could visualize this as 1/2 times 1 over t cubed. And then I want t cubed, which I'm going to differentiate. 1/2 being multiplied, that's just a scalar multiple, so that's really easy. But t to the 3, I'm going to bring to the numerator and now make it t to the negative 3. And now I'm going to derive. The derivative of a constant is 0. Pop down, power down, negative 1/2 times negative 3 is positive 3/2. T is now to the negative 4. And our final step is 3 over 2t to the 4th. Here, 2x, the entire 2x, is being brought to the third power. So I know that f of x is really just some constant, some fraction, times 1 over x cubed. But what is that fraction? It's not 5 over 2, because 2 is also being cubed. It's 5 over 8. 1 over x cubed, I can rewrite that as x to the negative 3. And now I'll derive. F prime of x is equal to, pop down, power down, negative 15 over 8, x to the negative 4. So negative 15 over 8x to the 4th. Fun fact, in AP, you don't have to simplify. So this would have been an acceptable answer. This would have been an acceptable answer. This would have been an acceptable answer. And the first one was just pretty easy. Since the derivative of a function is another function, we can repeat that and repeat that and repeat that. The result is still another function, which could again be differentiated. These derivatives are called higher order derivatives. So the first derivative we see here, y prime, f prime of x, dy dx. Differentiate with respect to x, f of x. Okay, then we have the second derivative, y prime prime, f prime prime of x. The second derivative with respect to x, the second derivative with respect to x, and so on. For this, we're going to find f prime of 1. We're going to first differentiate and then plug in 1. Oh, we are also going to find f prime prime of negative 8. I will begin by rewriting this to be 1/2 times, and I have I have 1 over x to the 2/3. The root becomes your denominator, x to the 2/3, but I'm going to bring it up, so x to the negative 2/3. Let's derive f prime of x, pop down, power down, is negative 1/3. X to the negative 2/3 minus 3/3 is negative 5/3. Now there's absolutely no reason for me to simplify this. No reason for me to put this in the denominator. I can plug in 1 into that. That's nice and easy, okay? 1 to any power is just 1. I will need to derive again and plug in 8, so I like it to be in this format because it'll be easy to derive again. First, I will plug in 1, and I get negative 1/3 times 1. So negative 1/3. All right, I'm going to take this and derive it again. So find f prime prime of x. That's going to be positive 5 over 9 x to the negative 5/3 minus 3/3 is negative 8/3. Now that I'm going to need to rewrite because I don't know what negative 8 to the negative 8/3 is off the top of my head. Is equal to 5 over 9. I am more comfortable with root notation, radicals, so I'm going to write this as the cubed root of x to the 8. Now the order of this does not matter when you're putting it. It could be cube root of x and then to the 8th or other way around. F prime prime of x is equal to, not of x, we want to plug in negative 8 now. 9 over the cube root of negative 8 to the 8th. Listen, I know the cube root of negative 8, so instead of doing negative 8 to the power of 8, I'm going to cube root first and then do it to the power of 8. Exponents and roots have the same, go in the same order for PEMDAS. So f prime prime of negative 8, that's 5 times 9. The cube root of negative 8 is negative 2 to the power of 8. And we get 5 over 2,304. Since the derivative of a function gives us the slope formula for tangent lines to the graph of the function, the derivative can be used to find equations of those tangent lines. Sometimes we will want to find a line that's perpendicular to the tangent line at a certain point. Such a line is called the normal line, a normal line. A normal line is the line that is perpendicular to the tangent line at a certain point. So, as we know from the relationship of perpendicular lines, the slope of the normal line is the opposite reciprocal slope of the tangent line. Find an equation of the tangent line of this at 0.16. So first I will derive, because I need to know the slope anywhere on this function, and then I need to know the slope at specifically the point 1. F prime of x, we can use power rule for this. 20x to the 4th minus 6x plus 0. So here is my derivative. I need to know the slope at x equals 1. And that gives us 14. So I have a slope. Do I have a point? Oh yeah, they gave me a point. So I can write the equation of the line. I'm going to use point-slope form because they gave me a point and a slope. Y minus the y value equals m times x minus the x value. They asked us to find an equation of the line. This is an equation of a line. So we're done. Find an equation of the normal line to the same curve at the same point. Okay, so if the slope of the tangent line was 14, the slope of the normal line will be negative 1 over 14. And the point is still 1, 6. So plugging that into point slope, I simply replace the 14 with a negative 1 over 14. And this is also an acceptable equation of the normal line. The normal line is perpendicular. Normal, perpendicular.